Hey guys, welcome. We are diving a little deeper into function families today. And if you haven't done this slide, please do it first. And then we're going to go through three types of function families, which is linear, quadratic, and exponential. All right, so let's get going with this. Okay, so with any family, you have differences. You have lines that go up, you have lines that go down. All right, so they can look different, but if they are part of a function family, and right now I'm talking about linear functions, they're always going to look like a straight line. You're not going to have any bends, you're not going to have any wiggles. So we are focusing on what is common with all of these linear functions. Oops. Okay. All right. So first, linear functions are always a line. You guys are super familiar with this equation, y equals mx plus b. So if you see any equation in that form, linear function. The parent function, which is shown here, is just the simplest version of that function. All right. So the slope is just a 1, and we don't even have a y-intercept. That's 0. So I guess we do. We have it at 0. And what's new, I think, is looking at sequences. So when I'm looking at this sequence, I can't see that it's going in a straight line. But it does have some characteristics that will tell me anyways that this is linear. All right, so I'm going to annotate with my pen. And I'm going to go through, and I've got 2 circles, and I'm going to 4, and then I'm going to 6, and then I'm going to 8, right? So from 2 to 4, and 4 to 6, and 6 to 8, I am always adding 2 more circles each time. Okay, so plus 2, plus 2, plus 2. Okay. Now in sequence C, I'm adding 3 each time, right? So I go from 3 to 6, add another 3 to give me 9, and add another 3 here to give me 12. All right. So these are sequences that you had yesterday. So I'm going through a little quickly, thinking that you guys have noticed and annotated these. But feel free to count with me and count on your own. 3, add another 3, that gives you 6, add another 3. Okay. All right. So now sequence E, I have 1, 2, 3, 4, 5, and I go down to 2. So here, 5 minus 3 gives me 2, right? So I had 5 circles, and now I just have 2 circles. So I had to get rid of 3. Okay. Now, these gray circles are negatives. So this would be like -1, and this would be -4. Okay. So to get from 2 circles, let me just put all of the numbers. So I got 5, 1, 2, 3, 4, 5. To go from 2 circles to losing 1, right? I again subtract 3. Okay, and -1, you guessed it, -3 gives me -4. So one of the characteristics of linear functions is that you are either adding or subtracting the same, or we call it constant, amount between each term. So some of you guys might know that the slope is called the constant rate of change. And that constant part is adding the same amount every time or subtracting the same amount every time. Okay, so yeah, so I could just look at these. Oh, I'm adding the same amount every time. That's linear. Okay, so now let's go on to the next one, which is exponential. All right, so now let me try to get rid of all of my annotations. All right, so exponential functions. think coronavirus, right? So part of the reason it was, so bad in March is because it was doubling every 4 days, every 3 days, right? So it wasn't just like, oh, two more people are getting sick each day. It's more like, oh no, 2 times the amount of people, right? So whenever it is growing quickly like that, like if I had money, I would like it to be exponentially growing. But in the case of coronavirus or something like that, growing so quick is really not good, right? So one characteristic of exponential functions is that they increase or they decrease super, super quickly. All right. This shape of, let me change that. This shape of kind of starting low and then it going straight up, or the reverse, where it's starting high and it goes sharply down. When I look at those graphs, that shape should tell you, oh, that's a characteristic of exponential functions. All right, so now how do we find it on sequences? Well, instead of adding the same amount, you are either multiplying, which both of these sequences are going to show, or dividing. So like if you started with a big number and it decreased sharply. Okay, so here I've got 2 circles. I go to 4 circles. I go to then 8 circles. And then I go to 16 circles. Okay, so I'm doubling, which is a fancy way of saying I'm multiplying by 2 each time. Okay, and here again, I'm multiplying by 2. So it's similar to linear functions where you're doing a constant thing every time. But the difference is in exponential, you're either multiplying or dividing instead of adding or subtracting. Okay. And in this one, you're multiplying again, but by 3. So again, you don't have to multiply or divide by the same amount for every exponential function. It just has to be the same multiplier or divider within its own. Like sequence K is going to always be times 3, times 3, times 3. Sequence I is always going to be times 2, times 2, times 2. Okay. All right. So let's go to our last one. And that is going to be quadratic functions. All right. So let's get rid of this annotation again. Okay. So quadratics are like if you're shooting a basketball, right? Or a rainbow. It's any of that like arc shape, okay? Or like a dolphin jumping out of the water and going back in, right? It's got a soft curve. It's not a V shape. It's kind of just like a rounded curve. And if, as you see here, if I'm reading it from the left to the right side, then the function is going down, it's decreasing. And then at a certain point, and this point is called a vertex, just FYI, then it starts going back up. So it changes direction. It either is down and then goes up, or it goes up and comes back down. This is a standard form for the equation. And again, the simplest form of a quadratic is y equals x to the second power, which is shown here, right? This parent function. Okay. And anytime you use this caret, that means you're raising the number after it to the exponent. All right, so let's get to the sequences. If you notice, you have the same kind of pattern. You start with a lot of circles, it decreases, and then it goes back up. Or you have not so many circles, like sequence Q, then it increases and it goes back down. All right. So those are a few of the characteristics. I'm going to tell you something called a second difference. All right. So the second difference is kind of, think of what we did for linear, of what's it added or subtracted, but we're going to do that twice. All right. So here I go from 2, 4, 6, 8 to 5 circles. So 8 minus 3 would give me 5. 5 circles minus 1 circle would give me this 4. And then to go from 4 circles to 5, I now need to add 1. And to go from 5 circles to 8, I need to add 3 circles. Okay, so am I adding or subtracting the same amount? No, so I know it's not linear, right? But how do I know it's quadratic? And here is how we know. We're just going to look at what I've written in blue and say, what do I need to add or subtract to get from -3 to -1? Okay, so follow along in your calculator if you can. So -3 plus 2 gives me -1. And -1 plus 2 gives me +1. And 1 plus 2 gives me a +3. So this second difference, if it is constant, then that is another characteristic that this is a quadratic function. So you don't even need to see the graph, the equation, or even I could not give you term 4 and 5, and you could still tell me that this is a quadratic function based off of the second difference numbers being the same. Okay, so that's all I have for you today. Good luck with the Desmos assignment and starting your statistics project, which is due next Friday, the 30th. Good luck.